Um, and so, because you're talking about a lot about general relativity, um, I've heard of special relativity, and just wondering if you could make give me some clarity in the difference. What I understand, I think, is one takes into account the radius of the curvature of space or something like that, or like there's some kind of curvature that's in one that's not in the other. But that's about it. So uh,
Okay, so what you said is true, but there are probably easier ways to say it. So, um, special relativity
yeah,
talks about um, objects moving, and in order for special relativity to be different from what you're used to day, walking down to the pub, things have to be moving very fast.
okay,
So, things like clocks slowing down and things shrinking and so forth, that only matters if things are going incredibly quickly.
okay,
So, special relativity says there's no gravity. It says that space is not distorted in any way, and objects can go near the speed of light. And then all the weirdness that happens. The difference between special relativity and general relativity is that now you turn on gravity. So general relativity still talks about things going fast. You still get the clocks changing, you still get things shrinking and so forth. But now because gravity exists, space can distort. And so instead of having a flat space, you have a you can have a curved space. And then that's kind of funky because if you're on the surface of a table and you roll a marble, it goes in a straight line.
yep,
But on the surface of the earth is after all curved. If you roll a marble, well, if you rolled it hard enough, it would be a circle. It would go all the way around the earth. So it'd be this. So it looks like it's moving straight, but if you look at it from the outside, you see, it's a curve because the space is curved. And so in general relativity, what happens is matter and energy take space and twist it. But other than that, that's the only difference. In both cases, they handle fast things, no problem.
yep.
But special relativity, no twisting of space. Special relativity, space is twisted. And basically that means no gravity and gravity.
Wait, sorry. Special relativity,
Special is no gravity,
no gravity.
and general relativity is gravity.
Okay, cool. And
Well,
so
let me say one last thing. And just
yep,
the words themselves tell you something. General means general. It's like
yeah,
everything.
yeah.
Special is a specific case.
I see.
So, in the same way that men is a special case of humanity, special relativity is a special case of general relativity. General relativity is the bigger thing.
Okay, cool. And so taking it back to obviously the idea of the origin,
Yeah.
um, was something like general relativity kind of an integral part of why we know what we know, or is it just one of a list of different things? So how for example do we go from where we are to understanding the past? Because obviously we don't have like a time machine. So what kind of methods did they use in order to work out the the kind of things that were going on back then?
Well, that's hard. Um, General relativity by itself doesn't tell us anything at all about how the universe came to be.
Okay,
So,
cool.
because it's just a theory, and you need to have a lot of data to verify it. So, probably the earliest data that we had about the origins of the universe is in the mid to late 1920s. So, there were a couple of people, a woman by the name of Henrietta Leavitt, who was working out